dilation and its constructions, and an application of dilations. In 13-3, we'll look at a dilation and its constructions, and an application of dilations. Isometries preserve distance, so an image under isometry is congruent to the original image. A different type of transformation is created when a slide is projected on a screen. The objects on the screen are enlarged from their original size on the screen by the same factor. For example, we have a projector here with a small image, and as it gets sent to the screen, it gets enlarged by a scale factor of 20. Let's look at an example of a dilation. Each side of triangle A', B', C' is twice as long as the corresponding sides of triangle ABC. You can see here that the segment OB is congruent to the segment BB', and you could also see that the segment OC is congruent to the segment CC', and OA and AA' are also congruent, so we have a scale factor of 2. A dilation from the plane to the plane with center O and scale factor R being greater than 0, is a transformation that assigns to each point A in the plane to the point A', such that O, A, and A' are collinear. O is not between A and A', and OA' is equal to R times OA. O, it's its own image. It is possible to define dilations when the scale factor is negative in the same way as the preceding definition for positive scale factor, except that O must be between A and A'. Let's look at an example. I want to find the image of the quadrilateral ABCD under a dilation with center O and scale factor of 2/3. I will start by connecting the point O with each of the vertices of the quadrilateral. We will connect O with B. We will connect O with A. We will connect O with D. Finally, we will connect O with C. Now we want to find a scale factor of 2/3. Since we want to find a scale factor of 2/3, we'll take the segment OD and we will find 2/3 of that segment here. And let's call this point D'. I'm going to take the segment OC and I'm going to find 2/3 of that segment. Let's say it's here, and we'll call that C'. I'm going to take 2/3 of the segment OA, let's call it here, and we'll call that the point A'. And finally, I'll take 2/3 of the segment OB at this point, and we'll call that B'. So now we have a scale factor of 2/3 once I draw in this quadrilateral. There we go. We have A', B', C', D' is now a quadrilateral that's a scale factor of 2/3 from the original quadrilateral ABCD. A dilation with center O and scale factor R being greater than 0, has the following properties. The image of a line segment is a line segment parallel to the original segment and R times as long. The image of an angle is an angle congruent to the original angle. Show that triangle ABC is the image of triangle ADE under a dilation. Identify the center of the dilation and the scale factor. For this problem, notice that the segment AD is congruent to the segment DB. Also, the segment AE is congruent to the segment CE. AB over AD is equal to 4 units divided by 2 units, or a scale factor of 2. Similarly, AC over EA is equal to 6 divided by 3, which also gives us a scale factor of 2. So this shows that we do have a dilation of triangle ABC to the image of triangle ADE, and the center is center A. We want to show that triangle ABC is the image of triangle APQ under a succession of isometries with a size transformation. Notice that we have to orientate the triangles in the same position. So I'm going to do a half turn with the triangle APQ, and we'll meet up at a point here, and we'll call that Q prime. And we'll meet up at another point here, and let's call that P prime. Hence, we have a transformation of triangle APQ by a half turn in A to obtain triangle AP prime Q prime. C is the image of Q prime under a dilation with center at A and scale factor 2. B is the image of B prime, and A is the image of itself. Therefore, triangle ABC can be obtained from triangle APQ by first finding the image of triangle APQ under a half turn in A and then applying the size transformation with center A and a scale factor 2 to that image. Two figures are similar if and only if it is possible to transform one onto the other by an isometry or a sequence of isometries followed by a dilation.